Hi everyone, welcome to Mr. Wagid's math class. Have you ever thought about changing the tiles in the bathroom or the kitchen? Like tiling the floor or the bathtub or even this backsplash of the countertop. For you to do that, you have to know the area you're covering and how many tiles you need to buy, otherwise you're going to be wasting your time and money. That takes us to the first concept of today's lesson, which is perfect square. For you to understand that, what makes a square? That the length and the width are the same. So if I'm giving you the area of a square, can you find the side length of that square? Let's see how we can find that out. So what is a perfect square? Is this tile a perfect square? It is. What makes it a perfect square? That the length and the width is the same. So if I give you the area of this tile of 169, how can you find the side length? And remember, all the side lengths should be the same because it is a square. So if I take a measuring tape and measure the width of this tile, it's 13 inches. And if I measure the length, is also 13 inches. So each side is 13 inches, and that's what makes it a perfect square. Now let's move on to the next perfect square. Here's the second tile, has an area of 36. This time, without measuring the length and the width, can you figure out what is the side length of a tile with an area of 36 inches squared? Mental math, and I gave you an easy number because I know that number 6 times 6 equals 36. So the side length equals 6. It's a perfect square. Each side is also 6 inches. Here's the last one. Here's a smaller tile now. The area is 16. How can you find the side length? To find the side length, you need to think about which number multiplied by itself gives me 16. And it's 4. So the side length for this one is 4. But there is an easy way to do this, which takes us to today's lesson, which is finding the square root of a number or squaring a number. We will discuss the difference between squaring a number and square root of a number and how can we find it without measuring. There is an easier way to find the side length of a square if you are given the area. It's called finding the square root. So what is square root? Look at this number with the symbol. That symbol is called the radical sign, and the number inside the radical sign, which is the 9, is called the radicand. So if you're trying to find the square root of 9, that means ask yourself this question. What number multiplied by itself gives you the radicand, which is the number inside the radical sign? Since I'm looking for 9, so what number times itself equals 9? 3 times 3 equals 9. But guess what? There's another number. There's another number. I multiply it by itself, gives me 9. What is that number? It's negative 3. Because negative 3 times negative 3 equals 9. Negative times a negative is positive, and 3 times 3 is 9. For you to understand what that means, let's see, here's a number line. The square root of 9 can equal 3 on the number line. So that's what the square root of 9 equals, 3. Or it could be negative 3. So if I'm giving you a square with an area of 9 inches, what do you do with that 9? You just square root it. And the square root of 9 equals 3, so the side length is 3. The number underneath the radicand sign, which is the radicand, is 9. This 9 is called a perfect square. Why is it called a perfect square? Because the answer of the square root is an integer, which is 3. It doesn't have a decimal or a fraction. So an integer is a whole number that does not have a decimal or a fraction. Here's another concept you're already familiar with, but let's discuss it again. It's called squaring. Here's an example, 9 squared. That number 9 here is called the base. And the 2, which means to the power of 2, is called the exponent. And the exponent tells you how many times the base is repeated through multiplication. Because I'm squaring, that means I'm repeating the base twice, which means 9 times 9, and that equals 81. So squaring means multiplying the number by itself. To understand the value of squaring, here's a number line. Where would you put 9 squared? 9 squared would be right exactly on 81 because 9 squared equals 81. Review what we learned so far. If you have 3 squared, that's called squaring, which means 3 times 3, which is 9. Watch how the number got bigger when you are squaring that number. Now, if you use the radical or the square root of 9, that's called square root, which means which number multiplied by itself gives you the radicand or the number underneath the radical sign. So the square root of 9 is 3, or the square root of 9 also negative 3 because negative times a negative is positive. So square rooting the number, the answer will get smaller. Squaring the number, the answer will get bigger. Now we know that every number has 2 square roots. One square root is positive and one square root is negative because negative times a negative is positive. You got it. Find the 2 square roots of the following numbers. Here's the first number, the square root of 121. So you always, to find the square root, ask yourself the question, what number multiplied by itself gives me 121? It's 11. And negative 11, because 11 times 11 is 121, and negative 11 times negative 11 is also 121. Now what if you have a fraction? The square root of 16 over 9. Because 16 and 9 are perfect squares, then I can split that fraction with 2 different square roots. So split the 16, so the square root of 16, and then the square root of 9. The square root of 16 is 4, and the square root of 9 is 3. So the answer is still a fraction of 4/3. That's the positive one, and the negative one would be negative 4/3. To check your answer, just multiply those numbers. What's 4 times 4? 16. And 3 times 3 is 9. Now, when you're evaluating square roots or equations, they don't always ask you for both square roots, the positive and the negative. So I made a table for you to see. There's something called positive square root, negative square root, or both positive and negative square root. What does that mean? The square root of 36 equals 6. That's a positive. There's nothing behind the square root. So I'm looking for the positive square root of 36, which is 6. Now the negative square root of 36, that means find the square root of 36, which is 6, and I need the negative of that. So the answer is negative 6. And if you want both positive and negative square root, then the answer would have the positive and the negative 6 as the square root of 36. Let's practice with evaluating more numbers. Pay attention to what they ask in the positive, the negative, or both square roots. The first one is the square root of 100. Since there is no sign behind the square root, that means it's a positive one. So what number multiplied by itself gives you 100? 10 times 10. So the answer is positive 10. Now I need the negative square root of 1. So now I just need the negative answer. What number multiplied by itself gives you 1? 1 times 1. So the answer is 1, but I need the negative of it, so negative 1. Now I need the square root of positive and negative of 25 over 4. Again, those are perfect squares, which means I can split them into the square root of 25 and the square root of 4. The square root of 25, what number multiplied by itself gives you 25? It's 5. And what number multiplied by itself gives you 4? It's 2. But I need the positive and the negative, so I put both positive and negative. I can simplify that and gives you 5 divided by 2 is 2.5. But again, I need the positive and negative, so your final answer is the positive and negative 2.5. Now let's evaluate this expression that has a square root. Always when you're evaluating expressions, follow the order of operation. The first thing is parentheses. So if you see parentheses, that's what you do first. The second thing is exponents or radicals. and then you move on to multiplication, division, or addition and subtraction is the last one to do. So there are no parentheses, but there is exponents or radicals. I see the radical. So that's the first thing to do. Bring everything else down that you don't use. So the 8, bring it down, minus, bring it down, and the 4, bring it down. Now, there's nothing between the 4 and the radical sign, so put a dot there. That means you're multiplying 4 times the radical. Now, evaluate 1 over 16 is 1/4 because 1 times 1 is 1 and 4 times 4 is 16. The second step now that I see multiplication. You have to multiply 4 times 1/4 before you subtract. So remember, subtraction is the last step. For me to multiply fraction, I have to make the 4 a fraction by putting 1 under the 4 and then multiply across. 4 times 1 is 4 and 1 times 4 is 4. Now bring the 8 down, minus 4/4. Simplify the 4/4, which is 4 divided by 4 is 1. So you end up with 8 minus 1, which is 7. Your answer is 7. Here's another expression to evaluate. Please follow the order of operation, otherwise you're going to get your answer wrong. Parentheses, what's inside the parentheses is the square root of 36, so evaluate that. And the square root of 36 is 6, but make sure you leave it in parentheses. To the power of 2, bring the minus 10 down. Now 6 squared means 6 times 6, which is 36, and bring the minus 10 down. But did you notice something? You end up with 36, which is the same number inside the radicand. And that's because squaring and square root are the inverse of each other. So when you see squaring and a square root, cancel them out and just bring the 36 down and then minus 10. It's an easier way. If you don't remember, you have to follow the steps. But if you do remember, it makes it easy for you. Squaring and square root, they cancel each other because they are the inverse operation. You end up with 36 minus 10, which is 26. Here's the last evaluating question, just for more practice. You have 3, and then parentheses. Inside the parentheses, you have the square root. So follow order of operation would be what's inside the parentheses. Now look at the square root of 147 divided by 3. 147 nor 3 are perfect squares. So what do I do now? The easiest thing is to divide 147 divided by 3. What does that give you? Bring the 3 down and the parentheses. 147 divided by 3 is 49. So keep it under the square root of 49 plus 5. Now it's easier to evaluate the square root because the square root of 49 is 7. 7 times 7 is 49. And then bring the 5 down and the 3 outside the parentheses. Now what's inside the parentheses is 7 plus 5, which is 12. And multiply 3 times 12 equals 36. How about comparing the value of numbers using less than, equal, or more than? I cannot decide which number is bigger unless I evaluate each one. So the square root of 81 is 9 because 9 times 9 is 81. And 9 squared means 9 times 9, which is 81. 9 is less than 81, so the square root of 81 is less than 9 squared. Here's the last example for today's lesson. Find the radius of the circle. You have a circle. I'm giving you the area of pi 36 inch squared. How can I find the radius? First of all, write the equation of the area of a circle. A equal pi r squared. The radius is the distance from one point on the circle to the middle of the circle. That is the radius. So substitute in the equation what you already know. And I know the area is pi 36. That's all I know. Then bring the equal sign down and pi r squared down. I need to isolate r, which is the radius. Notice how you have pi on both sides. So do not replace pi with 3.16 because when you divide by pi both sides, they will cancel each other. Pi divided by pi is 1. Bring the 36 down. And pi divided by pi is 1. Bring the r squared down. Now I still need to isolate r, not r squared. So get rid of the squared. Remember, Squaring and square root are the inverse of each other, so to get rid of the squared, use the radical or the square root. So I will square root both sides of the equation to make the equation balance. So the square root of 36 equals 6, and the square root of r squared, watch how the square root and the squared cancels each other. You left with r. So the radius equal 6 inches. Thank you everyone for watching my lesson about squaring a number and the square root of a number. If you have any question, please put it in the comments below. I appreciate your subscribing and liking my videos. See you next time.